Hi guys, how we doing? Welcome back to another video. So in the last video we went into how simple HTTP calls work so that my PC over here, there, that PC is able to communicate with this IO-Link device simply by just going on the command line and sending a HTTP request. Now we're going to go a bit deeper. We're going to find out quite a bit more about this sensor and just like look into more complicated HTTP calls. Now, you might be thinking, do I need to know this? If you work with a PROFINET IO-Link master, then no, you don't. It's much simpler. As long as you're working in the tier portal environment, this is kind of more of an IT thing to do, but it's worth knowing and understanding actually. And especially, for example, we'll delve into the IODD file. So this video, we should kind of bring together a lot of the concepts that we've covered in the previous videos. So let me just pop up my monitor. Cool. So let's get my monitor up. So you can see there we've got our IO-Link master web server running. If I now come to, this is a Python app that I'm running on a dashboard. Ignore the, you kind of, I've only just made this just basically to explain the concept a bit more. So if I grab the sensor, somewhere back here. So as you can see there, when I trigger the sensor, it goes yes, no, yes, no. We've got a 250 millisecond pole on there. We could go faster, but that's good enough, right? And so you can see that I've got signal level triggering. I've got the temperature of the actual device. If I hold it, maybe will it heat up? I don't think I'll be able to get it up much more. Operating hours, 267 hours that this thing's run. Threshold, etc. Cool. So this what I'm doing here is this is just a front end UI that looks fancy, but essentially I'm doing the exact same thing that we did in the last video. So here, this PowerShell command where I set up the body tag and I basically say what am I doing here basically. So I'm doing a request. The CID, I didn't really cover this in the last video, but essentially if you was making 10 requests all at once, so 10 asks for information all at once, you can give each one of those 10 things an ID, each one of those 10 requests in an ID, and then the IO-Link master will respond back and tell you, okay, in response to CID 1, so request 1, here's your information. In response to request ID 2, here's your information. So it's just a great way of like bundling information. I think the way to think about that is a bit like go to Starbucks, you order a coffee, they write your name on the cup, that sort of thing. So let's just to show you what we did last time. If I copy this command and then I come to PowerShell and wrong thing, did it not copy? If I go, you bugger, come on, copy. It says it's copied now, okay. Paste, there we go. And if I hit enter, there, I get my value of 0. And so if I put my hand over it and then send the request again, I get a value of 1, yeah? So we covered that in the last video. Essentially what that looks like this is the PowerShell command. As a JSON request, it's just, I'm making a request, I'm giving it an ID 1, and I want the data here. This is as simple as it gets because this data here, which I'll show you how to look at that in the IODD file later. This data is just simple. It's just process data in. It's PD in, and it comes back in 1 byte or 1 bit with a yes or no, basically. So if we go a bit further now, let's look into actually getting the signal level. So that's how strong this signal is. So you can see there 435, 1800, 2500, 2700. So you can see, and I think 3445 is the max. If I go way back here, yeah, cool. So let's look into how we get this. This is essentially the same request here now. The only difference is instead of doing a PD in, a process data in, and a get data request, we're now going to do an IO-Link read acyclic request, and we're asking for specific data here. So we're saying data index at 236 and the subindex 0, and then we want the IO-Link master to give us that information. So if I copy this command, does that work? Yep. I come back here now and I paste. Now we're going to get a lot more information. So instead of just a very simple 0 and 1 there, we now have a whole hex and there. Cool. So if we go back here, this is what it looks like as JSON format. Still very simple. It's a request, and we're giving it this address, and we're saying at this address, but at index 236, this is what we want. So what we're doing, and I'll show you how to do this. The signal level exists at index 236, and when you ask the IO-Link master for that index 236, you get these 7 bytes of information. Yeah, so you got 7 bytes of information coming across. Now we want 2 of those bytes, i.e. 16 bits, and I'll show you how to find this. So we want the 2 bytes here, and these 2 bytes, they give us this read value here. So as you can see there, as I move back and forth, these 2 bytes are changing, and these 2 bytes give us our signal level. Pretty cool. So, and then the other bytes give you some more information. So for example, byte 3 gives you the signal quality. So if I put my hand on it like that, do we get a bad quality? No, we don't. Okay, yeah. So anyways, you can see there, that's how we, essentially when you write your, whatever you're doing on the back end, if you're not using PROFINET PLC and you're using one of these IoT devices, you need to figure out how to find this information. So the easiest way to do this is you say, okay, you've seen in the data sheet that this device gives you a signal level, yeah? It gives you a switching state and it gives you a signal level. Let's go find that signal level. So if you remember when we covered IODD files, I mentioned that like the last part of the IODD file is a dictionary. So if I just, I'm way down here now at the bottom, and I have an explanation of every single thing. So if I wanted local control in IO-Link mode, I know that it's got that name. So if I come up, let's just go back up to the top. This is the IODD file for this Pepperl+Fuchs photoelectric sensor. So you can see there, Pepperl+Fuchs, device ID. If I now do Control F and I type signal level, that shows up here. So signal level, and I can then copy and paste this. So this is the variable name or the ID of the signal level, yeah? So just try to zoom in there. TN_V mes data_mes value. That's what I'm after. So if I now come back here, Control A, Control V. So signal level is the human readable name of the variable. This is the actual variable. So if I now search and come up, I can find now in the IODD file, in the parameter section of everything, where this signal level is held. So now I'm not looking for signal level anymore. I'm dealing with TN_V mes data mes value. So if I now, yeah, we can work like this. So I've got vmes data collection, index 236. So just as you saw there, I had index 236. So when I select index 236, I'm going to get all of this information that is held in here, and I'm going to go for, let's do this. I guess you need to take, okay, I'm trying to think of how much detail to go into here. The bit length here of this index 236 is 56 bits. So this, all the information I'm going to get back is going to be 56 bits. I am interested in TN_V mes data_mes value, and that exists, record item here, this record exists at bit offset 40. So I'm interested in the 56 bits at index 236, and I'm starting from bit 40, and it's going to be 16 bits of information. So that signal level, this signal level here, is going to come at index 40, yeah, of sorry, at bit offset 40 of index 236, and there's going to be 16 bits of the I'm interested in the bit length of 16. If that makes sense. So if you think about it, yeah, 40, if you count 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, but obviously I counted that from 40, so it should be 55 for 16 bits. So from 40 up to 55 is the information that I want, and so I can then decode that information to say, okay, so starting from 40 to 55, that is my information. Why has it gone? Why's the signal level gone off? Oh, never mind. Cool. All right, so I think that is everything that you need to know. It's just kind of a rinse and repeat from there, really. Yeah, I don't actually think there's anything else. Cool. All right, I don't want to go too much. I think that's good enough. You know, the main way that I use this is I'll come and grab what I want. This was old school. This was like, you know, 2 years ago. This is how you do it. But I think now you would just copy and paste this whole variable bit here now and give that to Claude or ChatGPT, and it's going to figure this out pretty quick, anyways. Cool. All right. Thanks for watching, guys. At least now you should understand pretty well how these IODD files work. Give the whole file to Claude and it will figure it out anyways. But it's just good for you to know how to read the bytes. Cool. All right. Thanks for watching. I'll see you next one. Take care. Bye-bye.